Welcome back to our statistics learning session. Today, we'll be talking about students' test. Is one sample versus two sample method. We'll do a deep dive to understand how we can do one-sided versus two-sided versus one sample and two-sided test for a student's t-test distribution. How can we do that? That's what we're gonna do. And just for an overview, when we do students t-test distribution, we won't be using quantile of Gaussian distribution, but instead we'll be using quantiles of students t distribution. Now, let's deep dive into this topic. Starting with, we'll take random variable x, which is an IAD, and it has a normal distribution. It is not a standard normal, but a non-normal distribution, which is a two unknown, mu and a sigma square. And the goal is to test a hypothesis where null hypothesis is mu equal to 0 or mu is not equal to 0. This is a two-side hypothesis testing. Here, we have to assume that when the data is asymptotic, is asymptotic, then we have to assume that, and on top of that, we don't know distribution of the data. In such cases, we have to make an assumption that our data is a Gaussian distribution, and that's exactly what we did here. Now, we need to calculate the test statistics for students distribution, and we will call T. Here, we have written our test statistics as xn multiplied by square root of n divided by square root of tilde unbiased Sn. Unbiased sample variance, square root of unbiased sample variance. That's what has been presented here. Now, goal is to derive a expression which resembles something like a normal distribution at numerator and chi-square distribution at denominator. That's our goal, to derive the expression, something similar to that. How do you do this? We can do this starting with making sure that starting with adding sigma on top of numerator and denominator. That is, let me, that is, numerator sigma n will have a sigma square. These two we'll add those two and they will cancel out each other, so no problem. And we can further add under null, under h null, we can say that square root n sigma n under mu null divided by sigma n divided by square root of unbiased sample variance divided by sigma square. We can say this. Now, what's the next step? Next step is we can say that the numerator under null hypothesis is a standard normal, and under numerator it is a it is something it has a chi-square distribution, but chi-square n minus 1 divided by n minus 1. Now, this is a chi-square, but it's not exactly a chi-square, but it is something close to chi-square, where chi-square is n minus 1 divided by n minus 1. That's the distribution of the denominator. How do we get this? For this, we have to go back to the Cochran's theorem, where Cochran's theorem says that if there are two variables, if there are two variables z and v, then z is a standard normal and v is chi-square, then z is perpendicular to v. That's what they say. Now, if this is true, then we can say that v is a v is a as a xn minus 1 distribution of xn minus 1, and we can say that v is equal to n minus 1 unbiased variance divided by chi-square. We can say this. Therefore, it is n minus 1 chi-square. Therefore, Sn chi-square is equal to xn minus 1 divided by n minus 1. Therefore, Sn divided by sigma square is has a distribution of chi-square n minus 1 divided by n minus 1. That's why numerator denominator are like this, and hence they are independent of one another. So now this is what we have. So what's the distribution? The distribution of this is t n minus 1, because n minus 1, what is n minus 1? N minus 1 is degree of freedom. And how do we get n minus 1? N minus 1 is derived by this z divided by v divided by d. And what is d here? D is n minus 1. That's the value here. Or we can say this is equal to chi-square n minus 1, n minus 1. Therefore, this has a distribution of n minus 1. These are equal to. You can just say that they are almost equal to. Now, since moving on, we can further move on to say that n xn divided by is has a distribution of normal distribution, and s unbiased sample variance divided by sigma square is xn minus 1 divided by n minus 1, and they are independent of one another by Cochrane's theorem. Therefore, the statistics of student distribution is Tn minus 1. Now moving on, we can say that student test distribution with non-asymptotic level of alpha, which is in between 0 and 1, we can say that this test is defined by absolute value of test statistics that should be greater than q alpha divided by 2. Is a quantile of alpha divided by 2. And what is this quantile of alpha? Quantile of alpha is 1 minus alpha divided by 1 minus alpha divided by 2 is a quantile of a t minus 1 student distribution. It is not a quantile of standard Gaussian. That's what we would understand. In the end, let me quickly summarize what we learned today. We learned about student t distribution for experiment where we have one sample and it's a two-sided test h1 h2 where h1 is mu equal to 0 and where h1 is mu is not equal to 0. We develop a test statistics with a simple where Tn was equal to square root of n xn divided by unbiased square root of unbiased variance Sn. Then we derive from that the upper side is a standard normal while lower side is a chi-square distribution n minus 1, and therefore this was a stress test distribution. And from this we derive that Tn has a distribution of Tn minus 1 stress distribution. Now then we moved on to say that stress test with level alpha is derived by absolute value of Tn. It has to be greater than q alpha by 2, and q alpha by 2 is 1 minus alpha by 2 of quantile of stress distribution, not a Gaussian distribution. That's all for today. I'll see you next learning session. Thank you so much.